Hello everyone. In this video we're going to do an AB question. Okay, this is from the AB exam and it's from 2006 Form B. Okay, this is question 5. So consider the differential equation dy dx equals y minus 1 squared times cosine of pi x. So part A, on the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. Okay, so we have these 9 points, okay? So let's make our slope field at point 0, 0, 0. At 0, 0, at 0, 0, what do we have? Okay, so at x, y, 0, 0, we have 0 minus 1 is negative 1 squared, so that'll be positive. So we have 1 times cosine of 0. Okay, cosine of 0 is 1, so we have a slope of 1. Okay, so 1, 0, we have y equals 0 again, so that'll be 0 minus 1 is negative 1, squared is 1. So we have 1 times cosine of pi, okay? And cosine of pi is negative 1, so we have a slope of negative 1 over here. And that negative 1, okay, x equals negative 1, we have 1 times cosine of negative pi, okay? Which is also negative 1. Okay, negative pi is just going clockwise from the unit circle. Okay, so we have cosine of negative pi is negative 1. Okay, now what about if y equals negative 1? Okay, if y equals negative 1, we have negative 1 minus 1 is 2. Sorry, negative 2 squared is 4. Okay, so we'll have 4 times cosine of 0, which is 1, so 4 times 1 is 4. Now, at cosine of pi, that's negative 1, so I have negative 1 times 4 is negative 4. Okay, and at negative 1 comma negative 1, it will be the same deal, because the cosine of negative pi is negative 1. So we have this over here. Now, what happens if y is equal to 1? If y is equal to 1, then y minus 1 squared will just be 0. And 0 times anything equals 0. So we have this flat line, because all the points of y coordinate 1 will be 0. So we've just done our slope field. Okay, so part B. There's a horizontal line with equation y equals c that satisfies this differential equation. Find the value of c. Now, you can use the slope field we just made to have a pretty good guess at what c might be. Okay, and we could see quite easily that c is equal to 1. Okay, because at y, the line y equals 1 will be flat. Okay, it's flat and it satisfies it because the slope field shows it. Okay, and if you plug all the points at y equals 1 with y coordinate 1, the slope will be 0. Okay, so it does indeed satisfy the differential equation. Now, part C. Find the particular solution y equals f of x to the differential equation with initial condition f of 1 equals 0. Now, we have dy dx equals y minus 1 squared times cosine of pi x. So what we have to do is use separation of variables. We divide by y minus 1 squared. Okay, and multiply each side by dx. Okay, and we integrate. So we have the integral. You take the integral of each side. Okay? Now what do we get on the left side? Okay, you can use u substitution here. Like u equals y minus 1. Okay, so du will just be dy. Okay, and we get negative y minus 1 to the negative 1, because y minus 1 squared in a denominator is the same as y minus 1 to the negative 2 power. Okay, and that equals, well, the integral of cosine is equal to sine. Okay, and if we let u equals pi x, then du equals pi dx. So we need to introduce a 1 over pi. You need to introduce a 1 over pi to the integral to the right over here so that we can have a pi inside the integral. Okay, and you need a plus c over here. So if we just recap what we have 1 over y minus 1 equals sine of pi x over pi plus c. Okay? So it satisfies initial condition 1, 0. Okay? So what we can do right now is we can plug in to find c, because c is conveniently placed. Okay? So if y equals 0, okay, if y equals 0, we get 0 minus 1 negative 1. Okay? So negative 1, and a negative of that is 1. So the 1 equals sine of pi x. Okay, so we have sine of pi x. So if x is equal to 1, we have sine of pi. And sine of pi is equal to 0. Okay, so 1 equals c. And we just solved it. 1 equals c. So our constant will be 1. So again, we could rewrite it as negative y equals 1, y minus 1 equals sine of pi x, okay, plus pi over pi. Okay, we're just adding this 1 and adding this 1 to the entire fraction. That makes the fraction a lot easier to handle. So we're going to take the negative of both sides. Okay, so we can get rid of this negative sign. Remember, we're trying to solve for y. Okay, so we have negative sine of pi x plus pi over pi. Okay, and we can take the reciprocal of both sides. Okay, so we can flip these fractions. Okay, take the reciprocal of both sides. So you have y minus 1 equals pi over sine of pi x plus pi. And if you add 1 to both sides, you get y equals 1 minus sine pi over sine of pi x plus pi. And that is the solution. That is our particular solution to the differential equation with that initial condition f of 1 equals 0. And we're done. We just solved this differential equation. Okay, it was not super hard, because as long as you know how to separate the variables and solve for a constant of integration, these questions are really not that hard. Thanks for watching. If you have any questions, and please comment down below and like this video. See you next time.